Hello everyone, welcome to this video, which is part of a series of videos that I'm making about designing supply chain networks. Now, this is a continuation of a previous video where we started looking at the problem of Lightning Networks and merging the supply chains of two different companies, Lightning Networks and Satellite TV. They merged together and they're calling themselves Lightning Networks now. Now, one of the Lightning Networks was a wireless company, while Sat TV was a satellite company. You're merging the two together. In the previous video that I posted, we looked at what happens if you kept the network as it is. So without making any changes, if you just ran the network as it was, what was the cost of the distribution network? And you found out that the total cost of the distribution network was 6.283 million. Right. So this is if you made no changes. Right. So I'm going to call this existing network. Right, so that's the existing network. So it's part one of the problem. So in part two of the problem, question says, should Simone make all warehouses flexible at an additional cost of 200,000 euros per year? Now let's make sure this is cost per warehouse. Okay, this required an investment of an additional annual cost of 200,000 euros. Simon short-term decide whether to make all warehouses flexible or not. This required an investment of an additional annual cost of 200,000 euros. Flexible warehouses, however, could be used to serve both wireless and satellite products. Now remember that this 200,000 euros. Oh, 1 second. I had some messages come up. I'm sorry. Okay, so remember that this 200,000 euro cost is a one-time cost, and it is not a cost that is incurred per warehouse. It is just a flat 200,000 euro investment that is required to make all the different warehouses that you have flexible. By flexible, you mean that Madrid will now be able to manage both wireless and satellite products in the same warehouse. But remember that the capacity doesn't change. The capacity still stays as 370, right? So with this in mind, what happens to the wireless network? Is it more expensive? Is it less expensive? How much is it going to cost? And that's what we're going to talk about in this video, right? So should we make the warehouse flexible, right? So what I'm going to do is I'm just going to make a copy of the sheet because a lot of it is already set up. I don't want to create a copy of this. Right, so this is just part 2, flexible network, right? There you go. Now, the main first thing to remember is that there is no different types now. All warehouses can handle all types of products, right? And so I'm just gonna delete this. We don't need that. All right, there you go. Now, a couple of things to remember. When we wrote our supply constraints and when we wrote our demand constraints here, we only considered, for example, when you write the supply constraint and say capacity is 370, we only looked at the wireless variables. But now we have to look at all the variables. And same goes for demand. When you wrote demand, we only looked at the wireless variables. Now we have to look at all the variables. I'm sorry, I shouldn't put it that way. We only looked at the top 3 warehouses because they were specialized as wireless warehouses. Now all warehouses can handle both products, right? So we have to make that change. So we have to make that change everywhere. So first I'm going to get rid of the numbers that we have here. We'll start from scratch. Not that it matters. You can keep these numbers here. Once you go and click on solve, Excel will come up with the right solution, whether you keep the right numbers here or not. Let's begin with the total cost, right? So total cost is also going to change because this sum product function was for the wireless, so this is the total fixed cost. That's the total fixed cost. This is the sum product function representing the variable cost for the wireless, and this is the variable cost for the satellite products. But now we want to be able to supply all of these products from all the different warehouses. So we're going to have to make that change, right? So when I write the sum product representing the variable cost of all the wireless products, now I'm going to choose all potential warehouse locations going to all demand locations. So this is number of units supplied from Madrid, Rotterdam, Krakow, Toulouse, Munich, and Budapest to all the different demand regions, but specially only for the wireless products, right? So so all of these variables, comma, don't forget the comma, all the variable cost, right? Because you are sending all products, you're sending all wireless products from all the different warehouses. Similarly, when we do the second sum product, oops, we are going to choose all the satellite variables from all 6 warehouses and the same variable cost, because the variable cost is the same, right? There you go. Now, one other thing that we have to add here is that we have that extra $200,000 cost, that's 200,000 euro cost, so 200,000 euro, that's the extra cost for making the warehouses flexible, a single one-time cost, right? So that's the total cost right now. That's all the fixed cost values plus the $200,000 cost, no, 200,000 euro cost. Now let's look at the supply constraint. The supply constraint says that you have a capacity of 370,000 in Madrid. And this capacity has to serve both wireless products and satellite products coming out of Madrid. So here, when I write the constraint, I'm going to say the sum of all the wireless products coming out of Madrid. This is all the wireless products coming out of Madrid, going to all the 6 different regions, plus the sum of all the wireless satellite products going out of Madrid. So sum of all the wireless products and the sum of the satellite products. You could have written a single sum and chosen everything. I just split it up as 2 separate things. It doesn't matter. Excel will take care of that for us. This is the total sum of all units going out of Madrid, both wireless and satellite together. And they have to be less than or equal to 370, right? So I'm going to do the same thing. Now, because I wrote the formula the right way, I'm just going to copy it all the way down. Let's check for Munich. So if I check Munich, it'll say all the wireless products going out of Munich plus all the satellite products going out of Munich has to be less than or equal to the capacity, which is 290,000, right? So we have fixed our capacity constraints, supply constraints. Now look at our demand constraints. So this is the wireless demand. So we know that these are the demand values in the different regions. So the wireless demand, so is the sum of all wireless demand. So all the wireless demand going into the Northwest. So everything going from all the 6 different, coming from all the 6 warehouse locations. So this is the total wireless demand, and this has to be, so all 6 warehouses can satisfy this demand of 200,000, right? So I'd add up all 6 numbers. I'm just going to copy that formula out, right? So yeah, fixes for the Northeast, not just the top 3 warehouses, which were wireless before, but now all warehouses. And the same goes for satellite demand. So this is the total demand of everything coming into the Northwest region, all the satellite products coming into the Northwest region from all 6 warehouses, and they have to be equal to 120,000. So I wrote the formula the right way. I'm just going to copy it out. And there you go. So again, checking for the middle south, all the satellite products going into middle south. Right? Okay. Crucial thing to remember here is that we have made the warehouses flexible. We have added an extra $200,000 cost, but the capacities remained the same. That's why the capacity constraints are going to be some of the limiting ones. But still, let's. We already put this into solver, so I'm just going to move my head around. Right there. So the objective function is in the same place. These are my decision variable cells. The 2 demand constraints and the supply constraint. Everything is set up the right way. I'm just going to click on solve here. There you go. So how much does this cost? 6,253,000 euros. This is 6,283,000 euros. So you're saving about 30,000 euros, right? So the extra 200,000 euro cost that you incurred in making the warehouses flexible essentially got eaten up, you save that cost by adding flexibility in the warehouse, and you're actually saving 30,000 euros on top of that. So you're essentially saving 230,000 euros. Out of the 230,000 euros, you're paying 200,000 euros to make the warehouse flexible. So you're saving 30,000 euros. So yes, making the warehouse flexible is useful, but it wasn't that useful, right? You're only saving 30,000 euros when you have a cost of 6 million. Saving 30,000, it probably doesn't even show up as the third or the fourth decimal place when you do percentages, right? So can we save more? And that's what we'll answer in the next video. So I'm going to stop this video here. I'm going to try to keep these videos shorter. The first one was almost 30 minutes long. I don't want to be longer than, I didn't want to be longer at 10 minutes. We're already there. So I'm going to stop this here. In the next video, we're going to look at the next part of the problem. All right. I'll see you all in the next one. Take care.